There's a bit of an elephant in the room this week. For the past couple months, the cybersecurity industry has been having a very public debate about models like Anthropic's Mythos and what happens when AI becomes genuinely useful for vulnerability research and exploit development. This week, that conversation got a little more real. Anthropic released the first public version of the same model family it initially hesitated to put into the world. And whether you think that's exciting, inevitable, or a little scary, it sort of looms over this week's stories. The question is, what happens now that everybody has it? Welcome to Initial Access. I'm Sean McMillan, Community Manager here at Bishop Fox, and I am joined this week by Thomas Wilson, Senior Red Team Operator, Richard Brown, Senior Managing Operator 2, Sergio Villegas, Senior Managing Analyst 2, and Kendrick Urbaniak, Senior Operator Exploit Development. We got a full house this week.
Yeah.
And the elephant is still in the room. I see it.
he's
Get
sort
out
of
here,
fallen.
elephant.
Oh, then he's gone. He's gone.
Yeah.
Thank goodness.
I got to steal that prop from my daughter's room. She's expecting it back. First up, let's get into this from the hacker news. This is just, every once in a while you get a story that's almost unbelievable. And in this case, this is researchers traced a Linux privilege escalation vulnerability back to a single inverted character in the kernel's NFTables subsystem, the packet filtering framework that's used by modern Linux firewalls. The bug allows an unprivileged user to escalate to root, and in some environments, escape from a container into the host system underneath it. The interesting thing here is that multiple independent exploit paths emerged from the same flaw. There were two separate research teams that arrived at different ways of turning the same bug into root access. So that kind of raises some more questions, such as how we even think about patching versus exploitation. And also interesting, there was a 4-month gap between patch and public weaponized exploit. So what does that kind of mean for operators targeting enterprise Linux environments? I mean, is that long enough to matter?
That kind of seems like ages these days, right? I mean, with the rate that a lot of the dirty frag stuff hit and then was immediately exploited. Sure. A couple of months, even a couple of weeks feels like an eternity to me.
I think we're even getting to the point where a couple of days is a little bit too long for some of these vulnerabilities with AI speeding everything up. So yeah. A couple of months. Oof.
I think last couple of weeks we have talked about development of exploits that some of them took minutes, seeing the attacks, or a couple of hours, right? So this is a lot of time. And I think on the other side, right, what I'm saying is a bit of a pressure from the developers because Pound to Own was on those dates. So it was not that quick, but at the same time, it was a little time sensitive because of the Pound to Own. It's a great incentive.
Yeah. And especially with having multiple paths, but multiple teams trying to exploit the same thing. Now, the 4-month gap when you have legitimate people attacking it is even longer when there are illegitimate people attacking it as well.
Yeah. I wonder if this too is the us seeing in the wild is just a factor of the Linux kernel is kind of taking a bit of a beating. If you're not using SE Linux and really narrowly scoping what kernel modules you're allowing to be loaded into your environment, there's so many things happening right now. There are so many other fast routes, maybe this just sat unaddressed because there were easier ways to craft exploits, another variant of dirty frag or something like that, and just get in there and do something quick.
Yeah.
What do you guys think about the two teams finding completely different ways to exploit that? Does that raise concern in how you think about patching, or
I mean, I think as long as the patch addresses the underlying issue, ideally a patch fixes both methods of exploitation. But I guess if it doesn't, then that becomes a problem, obviously.
Depends on the patch, I guess. Yeah.
Right.
Yeah. I was going to say something similar. We've seen in the past, we call it regression when a patch doesn't fully fix it.
Yeah.
But we've seen this in the past where something is patched and then someone else dives deeper and realizes, okay, well, they blocked the cert, but you can still add your own cert. Now you're the patch was
it's like a half fix.
Yeah, I couldn't think of the words.
Yeah.
But
and in the past, something that we have seen, and I think this is the point, right? I don't see a concern, but I see something for vendors to really address. Sometimes what we are seeing is that the patches they release do not literally fix the issue, but they do kind of a superficial thing, right? Hey, I will change the version so your exploit checks doesn't check the version and it doesn't match, right? So you're not really fixing the vulnerability. You are just putting something on top of it. So I think it's beneficial that multiple researchers are trying different ways to exploit the same thing, because you will tell the vendor, or you will pressure them, right, into, hey, can you actually fix this thing, instead of like giving me nothing.
Yeah. Don't give them a
Security
hurdle,
by
give them
obscurity.
a wall.
Yeah, I think it kind of like draws attention to the fact that like we really need to, I think there's a little bit of a kerfuffle, in the community about, some of the Windows vulnerabilities we saw. But I think it like really highlights that it's good to incentivize independent researchers to do this, research and uncover new ways to exploit vulnerabilities, because that's there, right? You want to encourage people to find them so that you can make patches that are holistic.
Guess that they both used different AI models, and they both kind of merged down the same code paths to some degree, but took slightly different paths and end up with the same vulnerability at the end.
How dare you address that elephant? How dare you?
Man. All right. Well, let's talk from dark reading. This story really brought to mind Manchurian Candidate, which is one of my favorite movies, but I kind of hate to see it in practice. Researchers found a prompt injection issue in Google Gemini that allows malicious instructions to be hidden inside phone notifications. Gemini can read and summarize those notifications on a user's behalf, which means an attacker can potentially influence what the assistant says without ever interacting with Gemini directly. And that's kind of a strange thing that we see with AI systems, is that it's not like you have a line between data and instructions that is kind of blurry. And I think this is, am I wrong? This is just like, this feels like a creepy, like, this could happen to me. I use an iPhone. It couldn't happen to me.
I hate that I think it's cool. I hate that I love it.
I know, exactly.
It's definitely going to be that next, like, XSS everywhere thing. It's going to be prompt injection everywhere type of thing, because everybody's doing it. Everybody wants it in their app, and it's going to be a thing that people are going to have to lock down and figure out a actual valid workaround, whether or not it's guardrails that actually work, or if we're just going to give up at one time and just, having to stop using it. So it's going to be rough.
Yeah.
And I think we will continue to see this proliferation, right? I mean, it's fairly new, so I don't know if it's really proliferating that much. But of different or creative ways to do these kind of indirect prop injections, right? Because I think there was a paper back in 2023, if I remember correctly, where they kind of defined briefly this concept of, instead of trying to do these different escapes from your LLMs, you inject something else. And because of the urge of the LLMs to try and actually read, right? Like, they have this urge to actually understand what you are sending to them, what attachments you're putting there, right? They will actually try and read everything, and anything they read, I mean, it's good for them, right? They will try to execute something if they read something. So I think that's the interesting part. Like, how creative can you become with these different prop injections?
Yeah. I mean, the one that I think was mentioned in the article was wild too, because it's like encoded into a different language, and then it provides a prompt to the user. So it's like already the level of obfuscation here is like pretty intense. And I think that like we're going to see in the wild, if we see more and more of this, like that's going to be out there. Like, one of the things that's, Bishop Fox, we're doing some hiring, and I've been looking at kind of stuff that's been going on in like the LinkedIn recruitment space. And a lot of recruiters are putting prompt injection in their, here's an application that you can have, or people are putting it in their bios, and it goes both ways, where it's like people are prompt injecting everywhere. It's really intense.
The game and how to play it.
Yeah.
Wow. So we see this and we instantly think, like, or at least my first thought is like, what if that happened to me? What if Gemini started like just reading out, something that is a little off? But as an attacker, like, how do you turn that into something?
I mean, in this case, Gemini is basically like a very wide IPC. Like, it is, you think about traditional IPC exploitation and process communications on a mobile device, like you can maybe go from one app to another app. But if you've got a system-wide assistant like Gemini, anything you've given Gemini permission to, you're going to get access to that. So on a user's mobile device, if say they've given access to all their contacts to Gemini, you can get in through malicious app, and now you have contacts, even if you didn't give access to that app, access to contacts. attack. So it's like, it's a new wider blast radius for a malicious package or APK on a mobile device.
Yeah.
Yeah.
And we have to remember too, like this story in particular was on the user's behalf. So the user didn't have to have any interaction with it. So it's
Right.
not even necessarily like, you know what's going on. So you're not sure what you're actually losing in the background of this attack. So
Yeah.
Yeah.
yeah, I think weaponizing it from a pen testing perspective is harder because we don't really deal into the mobile attacks that affect everyone. I mean, we do dig into mobile phone apps, but I'm saying from a legitimate perspective, I don't know what use this would have for me to gain access into a corporation to show them the value of this.
Yeah.
Right. This would
You're not
definitely
going to
be,
see that.
yeah.
I think it'd be one of those ones with like malvertising type stuff where they do some prompt injection with Gemini, gets you some malware that you just like, oh, click on this. It's like, oh, Gemini is now giving me this thing to click on. Like, okay, it's crossing that trust boundary to some degree, and
It's
now I'm
being
going to install it.
helpful.
It's being helpful, right? I'm gonna download this new app, but lo and behold, it's from some guy that just wanted you to download this malicious package, and now you're installing it, and now you get a Bitcoin miner on your phone or whatever the new craze is these days, right?
Yeah. What I'm seeing is also a new way, and I think Kendrick described it perfectly, right? This trust boundary. If I really wanted to do this is more like a red team, maybe like very targeted exercise you want to do where you want to weaponize PDFs, send them over to some salespeople, executives like, hey, this is the brief of my product. What they will do, they will try and get a summary of the file instead of actually reading it, right? So it's good for them because they have AI assistants to do the work for them. But I think there is where you can get that for more, quote unquote, easily, right? It's not easy, but I think perhaps that's cheaper than setting up the infrastructure for a malvertising kind of campaign.
Yeah. I mean, I would argue that it's like one of the cases where like you probably wouldn't see this in any pen test because even in a red team operation, you're not going to get that sort of brew install from a thing that's going to be a fake AI assistant. You're not going to have people deploying fake packages because you'd have to put it on a store, right? Like you can't constrain the scope if you act like a real threat actor in that way, which is why frequently you got some level of assumed breach if you want to simulate that sort of attack or some combination of social engineering with more assumed breach access. But I mean, real actors, again, have no scope, right? So they're not going to be constrained in any way.
Or your company pushes out some new endpoint management system for phones and your Gemini tells you, oh, you got to install this endpoint manager for your job, right? So I don't know. I feel like it could be there, but yeah, scope-wise, you're going to be hard-pressed. So
tough to justify something like that. All right, well, let's talk bleeping computer. This Cisco disclosed an actively exploited zero-day affecting Catalyst SD-WAN, a platform many organizations use to manage connectivity between offices, cloud environments, and remote users. The vulnerability allows unauthenticated attackers to gain root access before a patch is available. Now, we've talked about root access on a workstation, but on a system helping direct traffic across an enterprise, that's something special. One of the recurring themes in modern intrusion activity is that attackers increasingly prefer infrastructure over endpoints. And this is exactly an example of that. I think this edge infrastructure like SD-WAN controllers keeps showing up as a preferred entry point. I wonder if you could just talk a little about what it is about these that makes them so attractive compared to more obvious targets.
When you're looking at these not necessarily they're edge environments, right? But they're very hard to, one, detect logs from them, and two, to reboot, which is what a lot of these fixes are, right? Oh, update firmware, reboot. I can't reboot something that manages all of my software-defined areas, right? So it's definitely going to be juicy for someone who's looking for persistence, or just that it's out there in general.
Yeah, absolutely. And I mean, like these endpoints, like if you've got some sort of WAN facing multiple users, right, or multiple people on the internet, for example, if you can get access to network infrastructure like this, even at the edge, you're getting access to whatever that organization or group has dictated that WAN is responsible for, or that infrastructure is responsible for. So the more you trust that point of failure, the more you trust that infrastructure, the bigger the problem is. And it varies based on the environment. Like some networks might have lots of different distributed VLANs. or what have you. But if you're able to get into network infrastructure, you kind of own that network from a communications perspective, not necessarily from an access perspective, but that is sure to follow, I think, in most cases.
And because it's on the edge, so it's always there. Like
Yeah.
you have infinite time to do the research. Like it's always there. So it's one of those juicy targets that you can just 6 months do the research. Now you
Just
can
a giant net. Yeah.
now you can do them all, right? So yeah,
There's a
search it.
reason why people are always going for vulnerabilities that they can find in these, because they're the real tradecraft of, I think, pretty advanced threat actors who want to get in that way.
100%. And kind of echoing that, that's why we see attacks being targeted like these concentrators of VPNs, right? Where you have all of the VPNs passing by. I think it was last week when we were talking about the cookie replacement, right? And you don't do it at the endpoint level, you do it at the actual infrastructure level. And that is why, right? That is why they are very targeted devices. And the other thing is because also the detection methods, I think it's much harder to identify that someone has access to your edge device rather than your endpoint, right? And I mean, no surprise, right? Attackers don't want to be seen.
Yeah.
So, yeah.
Yeah. How do you think an offensive operator thinks about what's reachable from there versus what a defender would assume is protected? Do you see like a regular kind of difference in that?
I think in some ways, actually, yeah. Like, I think when you're looking at that from a defender's point of view, you might know what you expect to be reachable. You might have like network diagrams that you've constructed and they inform your belief about what the network looks like. And then there's what's actually reachable, right? Which is a big part of the reason why we do pen tests in the first place, right? Your assumptions about a network are not necessarily going to bear out if you go and test those. So having access to a whole network through an edge device, you're going to see more than you might expect to. And it could take a lot of different forms, applications, a mail server, maybe a domain controller, whatever you want, but there might be some gaps there.
Yeah. I think it was last week we were talking about how defenders often think in terms of what their network is supposed to be like, and attackers don't know that, and they don't care. They spend a lot of time figuring out what it's actually like. So that makes sense.
Well, go ahead, Sergio.
No, I was thinking about this remembered me of certain stories. So I came from a blue team background. Actually, I did a lot of hunting back in the days. And I remembered that whenever they decommission like these edge or network devices, what they actually did is they repurposed them for like internal laboratories and stuff like that, but they never changed any of the rules and definitions inside those devices. So because they were connected in some way to the network, they actually were still exposed, right? Because they had like certain rules that particularly for like multinational offices, like BGP rules defined on the edge devices that were supposed to be decommissioned and are still connected to the whole grid and replicating. It sounds insane, right? But it happens. Why? Because those decommission processes do not work as they should. There is too many devices to manage. There is too many devices to attend to. And the security teams, honestly, they are super small in comparison to the amount of devices they need to protect and the amount of data they need to protect. That is what I was thinking about. Right
so when you decommission, you should take it out back and beat it with a hammer until the problem is solved.
I mean, yeah, when you think about taking over a server, I can talk to what the server can talk to. What's my one limiting factor there is my network. When I control the network, now I control what I can talk to from there, right? So now I control subnet routing, now I control VPCs, now I control other things that I didn't when I was on a server. But now being on this box, now I can control what I can poke at and talk to. Now I can have the server that was blocked off, now I can open up the gate and see what else I can do with it because I now own that infrastructure it sits on. So that's like just from an attacker perspective, a little more juicier than just hopping on a server and getting some passwords.
And
all right, let's talk about this one from TechCrunch. Microsoft temporarily restricted access to dozens of open source repositories after attackers compromised projects used by AI developers and injected password stealing malware. This is basically an attack on the tooling developers rely on to build those systems. Supply chain attacks have always been about leverage, and like really developer workstations kind of sit at a crazy powerful intersection of source code, cloud credentials, package registries, deployment pipelines, all that. So with it taking that spot in an attack surface, it often gets a lot of trust. how does an offensive operator think about this kind of target that gives access to credentials and secrets?
Yeah. I mean, this is an interesting story. I think, like, as a target, right, Microsoft is obviously huge. And if you can, infect products that they own and you get credential stealing, that obviously affects much more than just Microsoft. So I think there's a reason why somebody would go after their open source projects in that way. What's interesting to me about this is that Microsoft is huge. And I wonder, with big organizations like that, they probably are beating down attacks all the time. I wonder if we're really only hearing about this one because it's in those open source projects, right? If it's getting much more visibility because it was going to a place where they had to very visibly take incident response, and immediately kind of it had to be disclosed because people
There's
would
no
know.
brushing it under the rug.
Right. You can't, you can't, like, obviously, eventually the vulnerability report would go out, most likely, if they were dealing with something. But in this case, it's got to, like, people are seeing it right away,
Yeah.
I think we're going to see a lot more about the AI stuff, or like you're trying to steal AI credentials so that you can then do further prompt injecting type stuff in the future. I mean, that it's all boiling right back down to AI at this point. We got this which isn't
welcome to the show. It does every week.
Yeah.
Yeah.
So it's really just like one of those ones where we just want AI credentials so that we can then go do more work so that they can then attack more infrastructure so that they can steal more credentials.
Yeah.
I mean, we're just seeing I'm sure that's probably what some of this was doing, because they systematically went through and like took over different repos and that type of stuff. I'm sure they were using those tokens that they were stealing somewhere. And it'd be interesting from like an Anthropic or like a ChatGPT land to like see what those tokens were being used for, and then if they can correlate those going forward to a group. So
yeah,
there's a tiny addendum too to that, which I think is interesting in terms of like stealing AI credentials, right? Which is Microsoft is part of Glasswing. So if you get their credentials, you might have, I mean, I think, not to spoil our later stories, but you might get access to a model that maybe doesn't work as well if you're not working for Microsoft.
Yeah, for sure.
Yeah. This is a remnant of, I can't remember the malware, but it would infect your PC and watch your idle time. And when you were idle, it would do things because it could use your level of processing power, right? So like as an attacker, if you're really diligent on watching your token usage from Claude or anything else, if I can watch you not use it at night, now I'll hit your usage at night. Now I have this area where you don't even know I'm using your stuff because you're sleeping and your Claude's not doing anything. And now I can use it without you even knowing. And now I'm hiding in the background, kind of passively using your free tokens. And you're like, oh man, what's going on now? But
yeah. And the other thing I'm thinking right now is also the balance between how much access does Microsoft actually have to all of your repos and how much they are harvesting through LLM, right? Because if they detected somehow that there was password theft somewhere and decided to like take over those accounts in particular, right? Like, I think there is something, it was 3 weeks ago, if I remember correctly, when we talked about a similar story with GitHub, that they stopped certain accounts because of password theft, kind of a similar situation. And it's like, right, with, again, Microsoft is part of the whole AI ecosystem security now. So how much are they harvesting from your different repositories? Like, it's good. I mean, it's good, right? Glad they stopped this, but at the same time, it's kind of scary, right? Like, do I want to put my repos in there? I don't know, right? I don't know if I want to give them that much power.
Yeah.
Well, let's tee that up to actually talk about this Mythos thing. Let's get the elephant back in the room.
bring him out. Bring him out.
This is a moment right here. This is a podcast moment, industry moment. Earlier this year, Anthropic attracted a lot of attention when it declined to broadly release its Mythos cybersecurity model, citing concerns about the system's ability to discover and chain software vulnerabilities. This week, they released Claude Fable 5, the first public model built from that same family. The public version includes safeguards that route certain cybersecurity questions to a less capable system, while a more powerful version remains restricted to vetted security organizations. Whether those guardrails work is kind of the big question in the industry this week that we are just starting to get into. But it feels like we have moved from a kind of future problem state to maybe we're here. Are we here? What say you, the panel?
Nope. No, it's
unanimously.
it's functionally useless for a cybersecurity professional.
Yeah.
Which is funny, right? Like, so I think the one thing that just broadly speaking about LLMs that we've kind of really honed in on them being good on, or at least this is what kind of they're marketed as right now, is they're really good at cybersecurity and they're really good at biological, like cancer research, like that sort of thing.
Yeah.
This is stuff that like I can't speak to the second half. I can speak to the first half. They're pretty decent at that, and I can see why they would market it that way. But those are the two things that they don't let you do with Mythos. And it's like, okay, so we've developed this great model that can do these things really well, but you can't do them. You can still use them to, write a Naruto fan fiction if you'd like, but you can't use it for anything super, super practical.
It's so bad that if you have a person saying cyber in the next room over from you, it still just cancels its output and sends you back to Opus, and then you're done. Like, I guess I got to use Fable for all of like 5 minutes because the first thing I asked it to do was like summarize some news articles for me. And the first news article I went to go summarize, it looked at the news article and immediately is like, nope, it mentioned cyber in there and kicks me back to Opus. So I can't use it right now for anything besides personal use, essentially.
Yeah.
And this is what I was saying about like it being scary at a certain point, right? Like how much they are harvesting and how little we are getting back from it. Yeah, the guardrails they are putting are kind of absurd. Yeah, I don't want to say bad things about it, right? But it's kind of very intricate. Literally earlier today, I wanted to get kind of a summary for this podcast. And because I posted this specific news thing, it said, no, I don't want to say anything because, for safety reasons. It's like, I just want to get a summary of the article, right? I'm not trying to do any sort of like actual cyber investigation. So I'm wondering, like, something that will happen, and we will probably talk about this next week, is a lot of offensive people would get upset that they are getting these many guardrails and will try to evade them. So I will not be surprised if we get some articles through the few next weeks about like, hey, how to escape from your guardrails in your
It's like being an overbearing parent. The more overbearing you are, the more your teen is going to rebel. And so you put these really high guardrails in, and the security community cracks their knuckles collectively and says, all right, let's break this.
They will.
Yeah.
It is.
I was gonna say, it's a lot more tokens though, right? Yeah.
It is really odd because like the way that it's being, like the guardrails are implemented, they're on the better models, which implies that those models are better at doing that thing. But there's really no way to demonstrate that. Like it's being told to us. We're being told repeatedly that Mythos is so good at this, but we have no way of validating that as like a broader community. And maybe to a degree that's marketing, like maybe
sure.
And there's an interesting
marketing,
flip side.
Sure.
Like there's an interesting flip side to the guardrails thing too. I don't know if this is an article. I don't think we had that kind of teed up this week, but I saw people talking about malware that includes images of text baked into the malware that is basically saying, how do I make a nuclear bomb? And it's designed to trigger guardrails in AI to prevent AI-based analysis of malware. Because when the AI sees the image during reverse engineering, it reads that text, and the sidecar AI that does the guardrails sees that and stops analysis, right? And people have independently tested this. Like a lot of the models will just, like, even if you just post that image, you say, hey, will that trigger your guardrails? It's like, yes, they did. Like, I can't answer anymore. And so the guardrails actually hurt defenders just as much as they hurt attackers, because really who's benefiting from there being guardrails in place? Like hackers are going to find a way around them if they can, and people who really want to use a legitimate use case and get cyber verification, they can't use it still. It just doesn't do anything for them. So
I also am curious if this is like, there's been a lot of talk and early legislation talk about who oversees these things. And Anthropic has been one of the companies who has said, like, someone needs to make some rules here. We're just spinning this thing up. We hope someone makes some rules here. And I'm curious if this is something that might become a little more standardized, is that they make this powerful model, but they just put absurd guardrails in it because they just want to just get the toes out there and not release something that's going to become Skynet, you know? Like, I mean, they don't want to put the powerful thing out there and have everything go haywire.
It's not even that big of a deal from what I have been seeing from other people who've actually used like the unrestricted Mythos models. It's not that much better than Opus 4 point whatever it was at the time, because I think Opus has gone through quite a few iterations now since they released their Mythos. I think it went from like 4.5 to 4.8 now.
Yeah,
maybe 4.9. So it's like one of those things where they keep on teasing that this is so much better, but then I've also heard some of those same people have now been going right back to Opus because Opus actually does a better job in these later models of 4.8 and 4.7, that it just does better than Mythos in the first place. So why even bother using this super restricted 2x usage AI model that is good, but it's not that much better that it's actually worth the value.
Yeah, and somebody building an agentic infrastructure around, Sonnet can still, write something that'll compromise a whole domain, right? Like there's still, if people are applying real knowledge to the lower, complexity models, they're still able to achieve kind of the doomsday scenario that I think is being implied Mythos can produce.
Yeah. Well, I'm curious before the show, I got on Reddit. I know.
Nice. Classic. Let's go.
I could say that every week. I spend a lot of time on there. But I wanted to know like what the general sentiment was. And I saw a lot of this kind of like, you can get it to say hello and then it's going to stop you after that, And then I did see a few cases where people said like, hey, I can't use it for anything in cybersecurity, but I've got some projects running that I'm really impressed with. And I'm curious if you guys have had any successes so far. I mean, you guys are so embedded in cybersecurity, but if you have like, hey, cook me up some Dungeons and Dragons storylines or something unrelated to cybersecurity that you've seen any successes with.
People on the red team have, Jake specifically, has found some value in stripping out all of the indicators of compromise and stuff from some of the payloads we're working on and improving some of the more benign features in them. So it's good at that. We haven't really done like any comparisons to determine whether or not it's better or worse than Opus, but it does at least, it can help you with development. If you're a developer who wants to use it, that's certainly something. It doesn't like encryption.
There you go.
I think this reminds me of the story we had last week about like the meta thing, that if you kind of social engineer your way across the AI, it will trust it was actually you and trying to be in the place of another person, something like that, right?
Yeah,
I think this is a similar situation. What we are seeing is simple injections of, hey, I actually own this code, so you are actually defending, not attacking, so help me, right? Because as far as it's defending, right, or if it's actual researching purposes or nothing offensive, it will do the work, right? Like I think I shared a note with you guys, the story from earlier that I wanted to get the summary for the podcast. The only thing I did is like, hey, this is actually this is not unsafe. Just do the work. This is just some notes for myself, and it did work, right? It wasn't,
man.
Yeah. It's just a podcast, right? Like, I think that's and that's very tricky, right? Like, you are just telling it to trust you, basically. Like, trust me, bro, and it will do the work.
That's the big limitation there.
Yeah. Also, I mean, it's important to keep in mind too, like the guardrails like here that we're talking about are the ones that trigger independently, like the sidecar guardrails, right? Because like anything that happens within a model, I think this is important to keep in mind. Anything that happens within any LLM, any model that you're using, if there's not some outside interference that is observing a very limited context window and is like blocking access to it, you can convince any LLM to drift away from its system prompt, and you can make it do anything. No LLM can stop that by itself. There have to be outside controls. And I think that's why it's so frustrating, is because those outside controls are getting more and more aggressive, and people can still use tricks on the lower models to make them do really powerful things for good and for bad. And it kind of sucks right now that we're in a situation where not a lot of people can use this model for anything really useful because the sidecar is too aggressive.
Yeah. So I think the big takeaway here is just wait till you see 5.1.
Yeah, let's go. I mean, I'm still waiting for Fable 4.
Yeah. All right. Well, I think that's a good point to end on, and then we can get the elephant out of the room now. But I greatly appreciate you, gentlemen. Thomas, Sergio, Richard, Kendrick, thank you for joining. As always, if you found this useful, share it with someone in your organization. And if you're having successes with this new model, hit us up on LinkedIn or on X, Discord, and let us know what kind of successes you've had. All right, till next week, stay safe.